Hello everyone, welcome to another video in Grind 75, a better blind 75 coding series. So today's problem is on finding the product in of array except for the self element. So let's directly jump into the problem statement, understand it and start coding. Okay, so last time we have solved the coin change problem. You can find it as part of the list. Let's start with product of array except self. So yeah, I still have my cold running as you guys can notice from my voice, or maybe you guys can't. Okay, let's start. Given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except of I. The product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. Okay, you must write an algorithm that runs in O of n time and without using division operation. Now, why would they mention this without using division operation? Right? We'll come to it. So let's see what we want. You can see this is the input. For first, what's the answer? 2 into 3 into 4. 2 into 3 is 3 to the 6. 6 into 4, 24. Similarly, for 2, we can say 1 into 3, 4. 4 into 4. So 1 into 3, 3. 3 into 4, 12. 12. For 3, 1 into 2, 2 into 4, 8. Now, similarly for 4, 1 into 2 into 3. That is 6. So, we have to respond. The result is the product of all the elements except that element. Right? Now, before you think of any approach, the easiest solution could have been that you find out what's the product of the complete array and then you simply divide by the that current element, right? That's why they mentioned without using the division operation. So we are not going to use that approach. Now the solution is actually very simple but little slightly tricky. So I would suggest please pause the video, take a minute and think of the approach that we are going to take. Okay, ready? Now let's say what we are going to do. Okay, let's say when I am at 3. Okay, suppose I know what is the product of the left hand side array and what is the product of right side array, which is 4, and on this side this is 2. So for 3 I can say the answer would be the product on the left hand side multiplied by the product on the right hand side. Right? This way we are not using any division. Now there can be multiple approaches to solve this problem. I picked up the easiest one today, not the most optimal one, but the easiest one, because it's quite tricky and the solution would be really cool. So let's start. Okay, let's say, so we are sure that this approach would work, right? If I know the product of the left hand side, I know the product of the right hand side, I can simply multiply the left hand side by the right hand side, right? Like in case for 2, I can multiply by 1 into 3 into 4, 12. So 1 into 12 would be 12. Similarly for 3, I can do 2 into 4, 8. For 4, there will be nothing on the right, so we'll keep 1. And on the left hand side, it will be 3 into 2, 6. 6 into 1 will be 6, right? So we need to figure out the product on the left side and the right side. Now, why don't we do it this way? That we run through this array, we figure out the product on the left hand side. Let's say, like for 1, let's say our input is 1, 2, 3, 4. Okay, we create a left product array. Okay, and we'll initialize the left of 1 with 1. Okay, now for 2, we'll say original product 1 into this element 1, which is 1 again. Now for 3, it will be last product into this. So 1 into 2 is 2. So that means for 3, the product of all the elements on the left hand side is 2, right? Similarly, we'll come for 4 and we'll update 2 into 3. So overall product into 3, or you can simply say 1 into 2 into 3, right? which is 6. Similarly, we'll calculate the right hand side product. So we'll call it right product. That is equal to, we'll start from the right hand side. For 4, the right hand side product is going to be 1. Then we come to 3. For 3, right hand side product is the right element into the product that was found so far. So 1 into 4, not this side, it has to be here, 4. Right? So answer for 3 is 4. Similarly, for 2, it will be 3 into the product found so far. 3 into 4, 12. So we can say 12. Similarly, for 1, it is 2 into 12, which is 24. Or you can simply say 2 into 3 into 4. Right? So we'll write 24. Now, we'll calculate the result. Right? So result array would be, as we understood from our example, for anything we need to find out the product on the left hand side multiplied by the product on the right hand side. So for the first one, product on the left hand side for this is 1, right? And product on the right hand side for this is 24. So for 1 into 24 is 24. For 2, we'll do 1 into 12, that is 12. For 3, we'll do left product into right product. 2 into 4 is 8. And for 4, we'll do left product. 6 into 1, 6. And 6. As you can see, 24, 12, 8, 6. This is the final solution. Right? Pretty cool, right? Without actually using the division operation, we are calculating it. Now, also, since we are going to do it in 3 separate loops, our overall time complexity is going to remain O of n, which is the required time complexity. So without further ado, let's start coding. Cool. Okay, we'll say int n is equal to nums dot length. Okay, now we'll initialize our left array and the right arrays, left product array and right product array. So we'll say initialize arrays to store products to the left and right of each element. Right? So we can simply say int, we'll call left products is equal to new int of size n, because same size. Now int right products is equal to new int n, same size. Done. Similarly, we'll create one array for the result also, and we'll say initialize the result array. So we'll say int result is equal to new int of size n. That's it. Now first we'll calculate left product, then we'll calculate right product, and then we will calculate result. So I'll say calculate products to the left of each element. So we can first we'll initialize int left product is equal to 1, so that anything multiplied by 1 would be the number. That's why for the first element we'll get 1. And we'll say for int I is equal to 0, I is less than n, less than n, I plus plus. Right? And then left products of I is equal to left product. So right now left product is 1, so for 1 will go inside. Now we'll update the left product to multiply by the next number, or the current number actually. So we'll say left product into equal to nums of I. I'm sure everyone is aware, this means left product is equal to left product into nums of I. Nums of I is, where is nums of I? 1 in this case. So 1 into current 1 is equal to 1. So new left product update is 1. Then I plus plus, I reaches to next stage. left product of I is equal to left product, which is 1. Next time it gets updated 1 into 2, and next time it gets updated as 2, then 2 into 3, and next time updated as 6. Similarly, we'll calculate for the right hand side. So calculate products to the right of each element. Now we'll start from the right hand. Int right product is equal to 1. It will be the same set of code. Int I is equal to n minus 1. I is greater than equal to 0. I minus minus. Same approach. Right products of I is equal to right product, and then we'll update the right product. Right product into equal to nums of I. That's it, right? Now after these two arrays, we have calculated our left product, we have calculated the right products. Simply we'll calculate the result, which will be left product into right product for that I equal to from nums of I, right? So we can say calculate final result for int I is equal to 0, I is less than n, I plus plus, and then simply result of I is equal to left products of I into right products of I, right? That's it. And in the end we can simply return the result. Okay, so all we did is we calculated left product, right product, then the result is left product into right product. Let's understand it quickly. So for 3, this answer for 3 would be product of all the numbers on the left hand side which are covered here, like for 3 that is 2, and all the products on the right hand side which is covered here, which is 4. And then the solution would be 1 into 2 into 4. That means left side product into right side product multiplied by right side product. So 2 into 4, 8. Okay, let's run it and submit. So this is very easy approach. It was a tricky question, but it's easy approach. It's not that difficult once you understand it. Okay, beat 64.44%. So yes, solutions more optimal than this one does exist. You can check them as well. But this is the one which is simplest to understand and plus very easy to remember, right? So that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.